All right, here's our image storage class with two fields, compressor and filter. And here's the store method. Now, in this problem, the part that varies is the compressor and the filter we use when storing an image. To solve this problem, we need to apply the polymorphism principle of object-oriented programming. So we want our image storage to behave differently depending on the type of compressor or the filter we use. So we can introduce an interface called compressor with a single method called compress. Then we create classes that implement this interface, such as JPEG compressor and PNG compressor. With this structure, we are following the open-close principle. So if tomorrow we want to support a new image compression algorithm, we simply create a new class that implements the compressor interface. So we can extend our application by adding a new class and not by changing an existing one, okay? Now, in our image storage class, we should change the type of this field from string to compressor. So we want the image storage to maintain a reference to a compressor object. Now, when we create an image storage object, we give it a concrete compressor object, such as JPEG compressor or PNG compressor. That is how we're going to solve this problem. Now, we can use the same technique for solving the problem of filtering. So we introduce a new interface called filter with a single method called apply. And then we can create a bunch of classes that implement this interface, like black and white filter, high contrast filter, and so on. Once again, we're following the open-close principle. So if we want to support new filters, we simply create new classes that implement the filter interface. And that's what we call the strategy pattern. Now, you might be wondering where the name comes from. Well, here's the structure of this pattern that you see in the Django 4 book. So we have this context class, which is like our image storage. And this context maintains a reference to a strategy object. So this strategy is an interface or an abstract class that represents an algorithm, like an image compression algorithm. And then we have different classes that implement this algorithm. This is the idea behind the strategy pattern. Now, if you have been paying close attention, you might be thinking that this looks like the state pattern. Let me bring back the state pattern that we had earlier in the course. So earlier we talked about this canvas class that knows its current tool, and different behaviors are implemented by subclasses of the tool interface. So the structure of the state pattern looks very similar to the structure of the strategy pattern. So what is the difference? Well, we use both these patterns to change the behavior of an object. For example, over here, our canvas object can behave differently depending on the current tool. The difference between the state and strategy patterns is that in the state pattern, this object can have a single state, that is the current tool, and all these behaviors are represented by a subclass of this tool interface. In contrast, in the strategy pattern, we don't have a single state. Different behaviors are represented using different strategy objects. That is the difference between the state and strategy patterns. Next, I'm going to show you how to implement the strategy pattern.